Hello everyone. So today I'm going to talk about section 7.7, proportion and variation. Let's start with some definition. Um, Firstly, I'm gonna talk about the ratio. So what is a ratio? A ratio is a comparison of two quantities. So let's say like an example in meter two class, um, there are say uh, 20 boy and and um, and what I don't know, maybe and 15 girls, right? um so uh so so the ratio boy, say boy girl ratio in meter two class is 20, because 20 boys and 15 girls, right? So 20 to 15. So or I can write as 20 over 15. Okay, so that's is ratio. Um, okay, um, okay. Um, so what about a proportion? Okay, proportion. So proportion is a statement that two ratio equal. Okay, so what does that mean? Let's have an example. If I have say less x represent the number um, of um, say of girls um, in group one. Okay. Uh, so um, we we know that um, 20 20 boys to 15 girls as uh, x um, x so I should change this like 15 girl to 20 boy as x girls to let me see to um, four girl, four boy. Okay. Um, so we want to find x. I'm gonna use by setting the ratio 80. Let me write better. Ratio 80. No, sorry. 15 over 20 and x over 4. And equal to each other. So equal to each other. We obtain the proportion. Yes. 80, sorry, 15 over 20 equal to x over 4. Okay. So this is proportion. Okay. So in the units as girls over boys equal to girls over boys, right? So so that is setting that's using the setting the ratio, this ratio, you can get this portion, and then now you can solve this portion to find x, right? Remember the way to solve this, you can use cross multiply, right? You remember that in the previous one, and use this one with this one, this one with this one, right? You can use that. Okay, so you have 15 times 4 equal to 20 times x, right? And then you can divide both inside by 20. Or yeah, or you can actually multiply by 4 both inside. It's even easier and quicker. But yeah, let me, you know what, just gonna multiply by 4 both inside instead of cross multiply. So I'm gonna just multiply it by 4 both inside. So 4 both inside, right? So you're gonna see that the right hand side now have only x. The left hand side now, you know that this can be written as 4 times 15. No, 15. I'm gonna change it, become 3 times 5. For the 20, I can write it as 4 times 5, right? So you can cancel this 4 common factor, this 5 common factor, and you have x equal to 3 as the answer. All right. So yeah. So so I can say my conclusion is there are 3 girls in group 1. Okay. All right. Okay. So let's do another example. Say example number 1. So okay, so example number 1. 6 inches of light fluffy snow equivalent to about half an inch of rain in terms of water content. If 15 inch of this type of snowfall, estimate the water content. Okay, so so we are looking for what? We are looking for the water content. We estimate, right? If we have like 15 inch of this type of snowfall, so so we need to have what? We need to firstly I'm gonna have like let x say let me write it down. Okay, so I'm gonna write here solution, and then I'm gonna say let x be the um, equivalent 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 amount of rain. Okay, which is equivalent amount of rain, which is the water content. Okay, so so then we have 6 inches of snow to 1/2 inch of rain. As 15 inches of snow to X inches of rain. Okay, so we can write it in the form as so I would like to look for the water, right? So I would like to write X on the top. So X is amount of rain. So I'm gonna write rain on the top divided by snow equals to the rain on top divided by snow. Okay, remember that if you look for an X which is the amount of rain, then write rain on the top, because later on it just multiplied multiply the bottom, then you're gonna find X the right way. So let me show you why. Okay, so for the first ratio you have 1/2 on the top, right? Rain, snow, right? Snow is 6 over 6, right? Equal to now X over 15. Okay, you can rewrite it as like this better. Okay, so maybe I can, you can rewrite it as like this. Okay, so okay, 6 inch of rain R2 okay. All right, so you can write like that. Okay, let's move up. So now you can, what you want to do is you can just multiply it by the bottom over here. I mean multiply by 15 for both hand side, right? So you have the left hand side going to be 15 times 1/2, everything divided by 6 equal to x, because this cancel 15. Okay. Okay, so now I can consider this at the top, right? And I rewrite as 15 times 1 is 15, divided by 2 over 2, and everything divided by 6 equal to x. Okay, so this is a division between fraction in the left hand side. So what I need to do is I need to change it to become the multiplication. So it's going to be look like 15 over 2 multiplied by reciprocal of 6, which is 1 out of 6, right? And then equal to x. So now you can have 50, you can have x equal to 15 times 1 is 15, and 2 times 6 equal to, 12. This is going to be the answer. So 15 over 12 going to be the answer. Okay. So if in word, I can say 15 inches of light fluffy snow equivalent to about 15 over 12 inches of rain. Okay. Okay, what else do I have? Let me move down here. Okay. So we can apply proportion in a similar triangle. Okay, so let me draw it. So you have, say, two right triangle. Okay, this is the first one. This is the second one, bigger one. To this right triangle are similar. Say this is, I don't know, 60 degree, 60 degree, 30 degree, 30 degree. Okay, so these are similar triangle, and I'm looking for, I know that this solid leg is 5.5, this one is 8, this hypotenuse is 16, but this one I don't know. I'm looking for it. X. Okay, so how can I do it? Okay, so we can using proportion by so we know that side x to side x is to 16 as so x to 16 is as 5.5 to 8. So we can write as like x over 16 equal to 5.5 over 8. So see that I always put the I always try to put the x on the top. So later on I'm gonna just multiply by 16 both hand side, multiply by the denominator of the fraction that have x. So I have this as a hypotenuse over hypotenuse. Equal to shorter leg over shorter leg. Okay. So, to solve this, I can just multiply it by 8 for both hand side. Okay, let me use other color. Sorry, by 16. Multiply by 16 both hand side. So I have the left hand side become only x. The right hand side become 5 times 5.5 times 16. Now I can break it, become 2 times 8 divided by 8. So I can cancel this 8. And then 5.5 times 2 will be 11. Right? Easily. So now you can have x equal to 11, which is the answer. Okay. So if another problem, say example 2, okay, 2. Sometime in the real life, you want to measure or you want to calculate the height of the tree, right? But sometimes the tree is too high. You cannot climb to the tree and then use a measure to measure it, like how long, how high it is. That's not a good idea to do that, right? So this way, right, this the proportion that will help you to handle that. So let's say a 6. Let me see. Let me type better. Okay. So a 6-foot tall person cast a foot long shadow. Okay. If nearby tree cast if nearby tree cast a 36-foot long shadow, estimate the height of the tree. So so you can have like here, right? Here is the like person is here. Say person. This person is not a good picture, but you can know that this guy is 6 feet. Okay. What else? You have a tree maybe tree. Okay, here's a tree. All right. Let me use that color. Here's the tree. Okay. So what do I have? We don't know. We don't know how tall it is, right? I want to know this. This right? We don't know. So we got it is x. But we know the shadow with this guy. Shadow here is 36 feet. And also the shadow of the person here is 4 feet. So if I try to make it like a two similar triangle, two right similar triangle, it's look like this, right? It's like this. Here's 6, here's 4, and then imagine here's big one. Here's 36, here's x, right? You can imagine like that. And now you can just, using apply the way above from the bottom above to get the proportion. So I put the x on the top, divided by, so x here x here are let me see, that be the height of the tree, right? Yep. So you can say x over 6 equivalent to 36 divided by 4, right? So this guy and this guy, this guy and this guy, right? So now you can just multiply by 6 both hand side. Multiply by 6 both hand side to cancel this 6. So I have x, and I can have the right hand side become 36. I can write 36 as 2 times I don't know 2 times 18, and then no, I'm gonna just rewrite it as 4 times 9 and times 6 divided by 4. So this 4 gone, and then I have x will be equal to 9 times 6. We're gonna be equal to 54. Okay, so the height of the tree now is 64 feet. So you don't have to climb on the tree to measure how high it is, right? Okay, so so now I will talk about all right. Now I will talk about the direct variation. Direct variation. Okay, so let x and y, let x and y denote two quantity. Okay, and then y is direct, directly proportion to x, or another way to say it, or y varies, varies directly with x if y equal to k times x, for k is not equal to 0. Okay, k can be any constant number but not 0. Okay, and k also called the constant of proportion, proportionality, or constant variation. Anyway, just constant. All right, so how to solve, let's say, solving direct variation problems. All right, so let's follow 4 steps. Yeah, 4 steps. Step 1, so write the general equation. Step 2, substitute given values to solve for k. And then step 3, substitute k in the general equation in step 1. And the last step, step 4, use this equation to find the requested quantity. All right, so let's have an example to see how can we do this, right? Let's have example 3. All right, Okay, let me move up a little bit. All right. So example 3, let y be directly proportional to x or vary directly with x. Suppose, suppose y equals to 7. Let me write. All right. When x equal to 5. Oh my goodness, what happened? Then we're gonna find y when x equal to 11. Okay. So, let's have solution. So here is, I'm gonna copy down all this step and I show you. So step 1, how can I write the general equation for this? Okay, because y is directly proportional to x. Okay, so then I can write as y equal to kx. Right. Okay, y equal to kx. Okay. Substitute, that's step number 2, substitute the given value to solve k. What is the given value? I have y equal to 7 when x equal to 5, right? So I can just substitute y equals 7, right? And k times x now is 5, right? Right. So substitute y equal to 7. Y equals 7. Oh my goodness. And x equals to 5. To solve for k, right? And then now I'm going to solve for k by divide by 5 both hand side. Let me write it out. Divide by 5 both hand side. So I have k equal to 7 over 5. Okay. So now, let me move down this step. Now I can substitute k equal to 7 over 5 into the general equation in step 1. So what is that? Y, okay, let me write as k equal to 7 over 5, right? So 7 over 5 in the general equation in step 1. So I can rewrite, I can write as y equal to 7 over 5x. Okay. Okay, now I'm gonna use this equation to find the requested quantity. What does that mean? Okay, so let's go back. It said that find y when x equals to 11, right? Okay, so find y when x equals to 11. Let me show, okay? So you can just substitute y equal to, let me write it better. So I have y equal to 7 over 5 times x equal to 11. So put 11. Okay. And now you're going to use the calculator and you have 7 over 7 divided by 5, which equal to 15.4 as the answer. Okay. Okay, so that is for solving a direct variation application. Okay. Okay, now let's have another example. Oops, what happened? Here. Okay, so let's say example 6, example 4. Okay. Okay, in this example, I would have a scatter plot of data for the list of the tuition for taking various number of credit is shown below. Okay, so let me have here is caret, and here's tuition. So 3, 5, 8, 11, and 17. So tuition is $1.189, and then 315, and then 504, what 693, and then 1071. Okay, so the question for this is, could the data be modeled using a lie? Okay, so if you draw the graph, say the vertical axis is tuition, and the horizontal is credit. Credits. So from 0, 4, 8, 12, 16, and then 20. So H bar here is 4 unit. Okay, so okay, and then here is 250. Next one is going to be 500, and then 750. And what else? 1,000, and then 125. 1,250. Sorry. Okay, so now I have the first one is 3 and 189. So 3 could be here. 189 could be somewhere over here. So the first point is around here. So I'm gonna say here's 3189. Okay. The second point is 5, 3, 15. So 5 could be here. I'm gonna move up here, and then 315. 315 could be somewhere over here. So I'm gonna have another point here. So here's 5, 315. And then I have 8 with 504. So 8, 504. So here's 504 around here. Okay. So I'm gonna write as 8, 504. And then 11 and 693. Even around here. And then 693, which is almost 700. So around here. So here this one is say 11, 693. And then we come to 17. It's around here. And to move to the 1000 something. 1700. 1071. So around here. Seventeen 1071. So you can see that the data are linear, right? So the data, let me use other color. The data linear. Why is linear? You can just draw a line, go through this point, right? You see that? Not really nice, but it should like that, right? So you can say the data are linear and suggest a line go through a line goes through the origin. Okay. So now that is the answer. Now I'm gonna move to the B, problem B. Problem B, explain why tuition is directly proportional to the number of credit taken. Okay, so let's come back with the definition of directly proportional, right? So over here. Okay, this proportion is directly over here. So y is directly proportional to x, or y varies directly with x if y equal to kx. So if you have something like this, right, then y is directly proportional to x. Okay, so let's go back to here. Okay, you can see that each time. So here's a y. Okay, here is y. Here's x. Okay. I'm gonna just say that because the line go through the origin, right? So since it says no, how can I say? So the y-intercept gonna be the origin on it. So I'm gonna say because the data can be the data can be model by a line passing through the origin. Then it has in the form y equal to mx, right? Because in here b was 0, right? So y equal to mx plus 0, which is y equal to mx, right? So this is the form that we are looking for. We want it to be looked like this. So so tuition is directly proportional to the number of credit taken. Okay. So in here we can notice that k in here is m, the slope of the line. Okay. Let's move down. C. Find the constant. Oh, let me use that. Constant proportion. Approach proportionality. Okay. So we mean k. We mean k. We should know that in here k is slope, and I can just use the formula as y2 minus y1 over x2 minus x1, right? I'm going to use 2 point. Use 2 point. So one is 3,189. The second one is 1,071. And I will have it is I'm gonna say here's x1 y1, is x2 y2, right? Now I have k will be m will be equal to y2 is 1,071 minus y1 is 189 over x2 is 17 minus x1 is 3, and then I will have use a calculator and calculate this, and you're going to have k or m in here is equal to 63. So that means what? That means tuition is $63 per credit, right? Over per credit. Okay. All right. And general formula are going to be, okay, so D, let's say D. Let's move to the D. Predict the cost taking 16 credit. Okay, so remember that we have general form. Let me use article. General form is y equal to mx. Which now I know that m equals 63. Now it's 63x. So I can predict the cost taking 16 credits. So in here, x equals 16, right? So I have y will be equal to 63 times 16. We're gonna be use a calculator. We're gonna have $1,008. Okay. So that should be the answer. Okay. Okay. Now we're gonna move to inverse variation. Let me type inverse variation. Okay. So definition. Let's x and y denote two quantities. Okay. Then y is inverse proportional to x, or y varies inversely with x. If there is a non-zero number k, such as y equal to k divided by x. Okay, so it different with the directly proportional, right? So this is like called inversely proportional, or varies inversely. All right. Okay, so so let's try to solve how to solve. Right? So we're solving inverse variation problem. Okay. Okay. Let's have an example. Example 6. Let y be the inversely proportional to x, or varies inversely with x. Suppose y equal to 5y. Let me see. So y equal to 5, right? Y equal to 5. When x equals to 6. Okay. Okay. Then we find y when x equal to 21. All right. So we're gonna follow 6 step, I mean 4 step above over here. It's still using this 4 step, but we are set up with different general form. Okay, so here is solution. Step 1, we're going to write the general equation. So in here, because it say it is inversely proportional, very inversely, y is inversely with x. So I'm gonna write this as y. Let's say y equal to k divided by x. Okay. Okay. So remember that's k. In here, k is not equal to 0. Okay. Now, step number 2. So we choose the given values. I'm gonna say so we choose y equal to 5 and x equal to 6 to solve for y. So I have 5 equal to k divided by 6. Okay. And now you have what? You're gonna have solve it. So solve for k. Maybe I'm gonna write it like this so you can see it easily. 5 equal to k divided by 6. So what I do is I multiply both sides by 6 to get left hand side now become 30, right hand side now become k. So k equals to 30. Okay, and I can come to step number 3 and substitute k equal to 30 in general step 1, and I have y equal to 30 divided by x. And then now we're going to use the equation to find y when x equal to 21. Okay, so I'm going to substitute as y y equal to 30 divided by 21. Okay, so if I want to simplify it, I can rewrite it as divide with 3 points top bottom, have 10 divided by 7. Okay, maybe I'm gonna write it so we can see it. So I have 30 over 21 which it equal to 10 times 3, and then 3 times 7, so you can cancel this 3, have 10 divided by 7. Okay, that's going to be the answer, right? So all right, so far so good. Okay, now let's move down here. We're going to talk about joint variation. Let x, y, and z denote 3 quantities. Then z varies jointly with x and y if there is a non-zero number of k, such as I'm gonna have z equal to k times x times y. I'm gonna have a circle this one. Okay. All right. Okay, so let's do an example. Let's do an example. Example 9. Oh, before going to this one, I would like to have some formula for it. So some formula. So area of a rectangle, rectangle is A equal to WL. So W's width and L W is width, sorry, and L length. Okay. So what else do I have? I have volume of a cylinder. Which is V equal to okay, so this one I have to write. So I have V equal to pi r squared times h. In this case, In this case, the constant is pi, right? Okay, so now let's do an example. Example 9. So I have let me draw it. Wait. A string, the string S of a rectangular beam. So here is a rectangular beam. Okay. So have this side is T, this side is W. Okay. So the string, the string S of a rectangular beam varies jointly with its width W and the square of its thickness T. If a beam 3 inches, 3 inches wide and 5 inches thick support 750 pounds. How much can a similar beam 2 inches wide and 6 inches thick support? Okay, so this is a question from example number 9. So let's have solution down here. Let me copy 4 steps. Okay. Step right here. All right. Uh-oh. Okay. Okay. So we're gonna still have like 4 steps, maybe 4. But now we need to write the general equation for this. For the strength of a beam is modeled by. Okay, so I should have strength of a beam is modeled. So this model by S equal to K times W times T square. You know what? Square like this. All right. Okay. and that's K is a constant, non-zero constant. Okay. So non-zero constant. Okay. So now I'm gonna substitute the given value to solve for K. Okay, so I have uh, here W equal to 3. Take T equal to 5. Okay, and then S equal to 750 pounds. So I will have 750 equal to K times 3 times 5 squared. Okay. Now I'm gonna try to solve for K by divide both hand side. How about I'm gonna divide both hand side by 3 and 5 squared. So divide both hand side by 3 and 5 squared. 3 and 5 squared. Okay. Then now I will have I will cancel this in the right hand side, and the left hand side now I'm gonna change to become 10 times 3 and 5 square on the top, and then 3 times 5 square at the bottom. So I can cancel this 3 and 5 square cancel, and now I have K equal to 10. Okay. All right. So this is okay. And I will substitute K into the general equation in step 1. I will have S equal to 10 WT squared as the module, the strength of the beam. Now I will use this equation to find, let me see, what the question? To find the beam with 2-inch wide and 6-inch thick. Okay. Okay, so I have S will be right better. So in here actually W equal to 2 and T equal to 6. So I have S will be equal to 10 times 2 times 6 squared. Now I'm gonna have 20 times 36. We're gonna be 720 pounds. Okay. Move to the next one. Actually, we have finished section 7.7. I'm going to talk about section 8.1 in the next video. And we'll see you guys next time. Okay.